Good afternoon and welcome back to those schools that are returning from half term. We hope you had a great time and thank you for joining us today for our live talk with STEM Ambassador Jess, who is an air quality consultant, and you'll hear more about that really soon. So in celebration of Green Careers Week, Jess will share insights about her role, explain air pollution and how it's monitored, and discuss steps that we can all take to protect the environment. Feel free to ask questions in the chat and Jess will answer as many as she can at the end of this talk. So now let's get started. Good afternoon, Jess.
Yes, hello. So my name's Jess and I'm going to talk to you today about air quality, what it is and why it matters. So to start with, air quality is the term we use to describe how polluted the air we breathe is. And a consultant is a person who provides expert advice in a particular field of science or business to a client, perhaps, who lacks that expertise. So that's what an air quality consultant is. So I studied environmental science at university, which looks at the science of many different environmental issues, including climate change, soil quality, water quality, air quality, ecology, landscape acoustics, geology, and even more. So I work now for a fairly small company, but we cover all of the different topics that you see here. So I get to work with people who do lots of different things, such as noise, biodiversity, climate change. So it's a really interesting job that I get to do. So what is air? So air is all around us all the time, but we can't see it. So what's it made of? So it's a mixture of different gases. And the air in the Earth's atmosphere is made up of approximately 78% nitrogen and 21% oxygen, and 1% of lots of other things. There's also small amounts of lots of other gases, such as carbon dioxide, neon, and hydrogen. And it also holds lots of tiny particles that we call particulate matter, or we shorten it to PM. So some particles, like dust and pollen, are natural, but lots of them come from human activity, such as soot, smoke, and other pollutants from car exhausts and power plants. And when there are too many little particles in the air, it can be difficult for plants and animals to breathe. So this diagram shows you a little bit about particulate matter. So the big light blue circle in the middle, imagine that's a grain of sand. Grains of sand are 90 micrometers in diameter. That's 90 micrometers across. And a micrometer is 1/1,000,000th of a meter, or 1,000th of a millimeter. So if you go back to your classrooms and you look at the millimeters that are on your rulers, it's 10 of those in each centimeter. It's 1,000th of one of those. So it is very small. So you know roughly how big a grain of sand is from when you go to the beach. Then you can see the green circle is the size of human hair. And then PM10, which is particulate matter less than 10 micrometers in diameter, that's the purple one. And then we also talk about ultrafine particulate matter, which is less than 2.5 micrometers. So you can see there that they're really small. And the size matters because the size of the particle means that it can get to different parts of your body. So when you breathe the air in, the particulate matter that's PM10, as you can see in the diagram of the lungs over here with the purple bits, they get all the way down into the lungs, but then get trapped. They don't get in too deep. But PM2.5, as you can see on the diagram with the blue bits in the lungs, PM2.5 can get really deep into your lungs. The other pollutant that I look at mostly is nitrogen dioxide. So NO2, which is known as NO2, that's how we write it down. So it's one molecule of nitrogen, one atom of nitrogen, and 2 atoms of oxygen. So together, those 3 atoms together make something we call a molecule. So imagine you've got the little purple monster in the middle. We could say her name is Naomi, and she's holding hands with Oscar and Olivia on either side of her. And that's what an NO2 molecule looks like. So it's a gas, and it's formed by burning of fossil fuels, so formed by combustion. And you can see a picture there of what it looks like if you create it in the lab. So it's very brown and horrible looking. So those are the 2 things that I look at mostly, particulate matter and nitrogen dioxide. So clean air is important because, well, for lots of reasons, really. Air pollution can affect your brain and mental health, which impacts on your ability to learn. When we breathe polluted air in, the small pollution particles can enter through our lungs, as I showed you earlier, and can impact on your breathing. So it can make asthma and conditions like that worse. It also enters your bloodstream and can impact your heart. So there's lots of conditions, heart and lung conditions, that poor air quality can make worse. So what stops our air from being clean? So here we've got a fireplace in someone's home. So if you have an open fire maybe at home or a stove, that can cause air pollution. We've got emissions from a lorry. Again, fumes from your chimney, a bus, a motorbike, a car. So all of those are, we've got 4 different types of vehicles there. And then we've got industrial emissions. So it could be burning things to create energy, or it could be burning things to turn into other things, or any other kind of chemical industry can cause emissions. And agriculture can be quite a big pollutant source. And we've got some more cars there in the form of a taxi. So as you can see, all of these things are to do with burn. And that's because that's one of the main ways that nitrogen dioxide and particulate matter is produced. So as part of my job, I look at the emissions that new developments might cause. So if someone wants to build a new housing estate on the edge of your town, they'll come to me and I will do what we call an air quality assessment to see what the impact of that development might have, both on the health of the people moving in to live in that place and also on the air quality in the area already. So we do this in a number of ways. We run a lot of what we call dispersion models, which is where we input all the information and we set them running, and they do lots and lots of calculations, and they predict what the concentration is going to be at various points around the site. So when I do those, I have to tell it where all the roads are and how many vehicles are on the road, how many of those vehicles are heavy duty vehicles, so lorries and trucks, and how many of them are cars. But the other way that we do it is that we monitor the air quality. So on this slide, we've got lots of different ways of monitoring the air quality. From the big units that you can see, these are what we call continuous monitoring units. And that's because they measure the concentrations every minute. And they use quite complicated chemical processes. And they're what we call reference methods because they are really accurate. But most of the time, we haven't got room for one of these big trailers. So if you'll see at the bottom left there, you'll see something called a diffusion tube. It's a small tube, about that big. It's got a little cap on one end, and the air goes up the tube and reacts with a chemical that's in a little mesh right at the top. And then we leave that out for about a month. And then we can take it back, send it back to the lab, and they analyse it, and they can tell us what the average concentration of nitrogen dioxide has been while that diffusion tube was out. And these are cheap and easy to put up, and they're not very accurate, but we can make up for that in other ways. And on the far right-hand side, we've got something that we use for measuring dust. This is called a Frisbee gauge, because it looks like an upturned Frisbee. And the particles in the air settle into the Frisbee and then get washed down when it rains into the bottle that's on the floor at the bottom. And then we weigh the bottle, and then we can see how much particulate matter has landed on our Frisbee while we were monitoring. So monitoring shows us a lot about the air quality. So this is a graph showing the nitrogen dioxide concentration at 3 different types of locations across a full day, across 24 hours. And it shows us that a lot of the pollution in our air around where we live is from road vehicles. You can see this because you can see that the monitor at the roadside, which gives us our orange trace at the top, gives us the highest concentrations. In the middle, the blue line is what we call an urban background. So that means it's in a town or a village, but it's not right next to a main road. And then the line at the bottom is the rural background. So rural means in the countryside, so away from any major pollutants sources. So you can really see on the roadside trace that you have a peak in concentration, so around 8 to 9 o'clock in the morning, and then it dips it down a little bit, and then it comes back up about 5 or 6 p.m. And that's because those are the busiest times of the day on the road. And if you think about if your parents work in an office type job, they're probably going to work about 8 o'clock and coming home about 5:30, 6 o'clock. Obviously, not everybody has jobs that work those regular hours, but a lot of people do, and that means there's a lot of people driving around those times. And you can see that that's also reflected in the urban background, because you're a little bit further away from the main source, from the roads, but you're still in that urban built up area with lots of roads around. And then in the rural background, you can't really see that pattern reflected because you're much further away from any of the sources. So all the monitoring that we've done for air quality over the years has shown us that, certainly for nitrogen dioxide in particular, the main source of pollutants in this country is from what comes out the back of your cars. So I'm going to ask you 6 questions, and we'll see how much you know about air quality. So I want you to put up 6 fingers, and if you get one of these wrong, you can put a finger down, and then at the end, when we've been through them all, you can see how many fingers you've got left up, and that'll give you an indication of how much you know about air quality. All right. So the first statement is diesel vehicles are often the most polluting vehicles on the roads. So I want you to think about whether you think that's true or false. And have a little think, and once you've decided if you think that's true or false, I'll reveal it. And this is true. So if you said true, you can keep a finger up. And if you said false, you can put one down. So yeah, this is true. Diesel vehicles are, in terms of our local air quality, in terms of nitrogen dioxide and particulate matter, they produce a lot more pollution than petrol vehicles. Our next one, you can always see air pollution. So what do you think? Do you think you can always see pollution? Do you think that one is true or false? Okay, we'll reveal the answer. It is false. So if you said true, you need to put a finger down. If you said false, you can keep one up. So yeah, it is false, but when pollutants are in our atmosphere but are not too concentrated, we can't really see it. But if we think back to that picture of nitrogen dioxide in the lab that I showed you earlier, it is a really horrible brown colour. And if you look here, we've got pictures of Mexico City, Los Angeles and Beijing. And particularly in the photo of Mexico City and Los Angeles, you can really see the brown tinge to the sort of fogginess in the air, and that's nitrogen dioxide. But these are very high concentrations. You don't normally see it in the air. Obviously, if we're talking about dust and particulate matter, you can often see that more easily than you can see nitrogen dioxide. So you can see a picture of a truck in the top left there on a road that isn't surfaced, and it's lifting all the dust into the air. So our next question, you can always smell air pollution. So what do you think? Can you always smell air pollution? Lock your answer in and we'll reveal that it is false. It's quite hard to smell air pollution. I think sometimes if you're in a city and it is very polluted, you can smell something that's wrong. So keep track of how you're doing. And here's another one. So if you're walking to school and you walk on the inside of the pavement away from the road, this can help you breathe in fewer car fumes. So what do you think? Do you think it's worth staying on the side of the pavement away from the cars? Do you think that will help you breathe in fewer car fumes? Have a think. Lock your answer in. This one is true. The concentration of pollutants, that's how much of them are in the air, drops off really quickly in what we call an exponential curve, which means it drops off really very quickly. So the further away from the side of the road you can walk, the better it is for your exposure. And the surface area for gases to diffuse through in human lungs is roughly the same size as a tennis court. So what do you think? So if you could stretch out all the little membranes inside of your lungs, do you think it would be as big as a tennis court? That's quite big. So lock your answer in. That one is true. So that's why air quality is so important, because we've got the size of a tennis court in our bodies absorbing all of the things that we breathe in. And the last one, it's always better to be inside a car to protect you from air pollution. So have a think. What do you think is better? Do you think it's better to be inside a car or walking alongside on the path? So lock your answer in, and it is false. You're actually exposed to more pollution if you're in a car than if you're walking alongside the same road. And this is because when you are in a car, the air that's circulated around your car is brought in from the front of the car, so under the bonnet. So you're actually pulling in air almost directly from the exhaust of the car in front of you. So you're right in the path of the pollution. Whereas, as I said before, if you walk along the path just a little way away from the cars, the further you can get away, the lower the concentrations. So how did you do? Have a think about how well you did. I hope you all did brilliantly. And maybe you can share that with your teacher afterwards. So what can we do about all of this air pollution? Well, there are two main things that we can do. On the left here, we've got reduce exposure. So you can plan your route. Say if you walk to school, you can plan your route along quieter roads so that you're not being exposed to as many emissions on your walk. We've got a picture of a hedge there because you can sometimes use vegetation to act as a barrier. So perhaps if your school borders a main road, you might have a large fence or a large hedge between your playground and the road, because that will block some of the pollutants. And you can also avoid sitting in queues of traffic. So you can try and plan your routes along quieter routes to work so that you're not sat in a queue behind the exhaust of the car in front of you. So that's how you can reduce your exposure. But the most important thing is about reducing emissions, because that's something that you can do that helps everybody. So here we've got some symbols. You can switch to an electric car if that's possible for you, or even a lower emitting vehicle. There are some petrol vehicles now that have quite low emissions in compared to a lot of the cars on the road. So even if you can't have a fully electric vehicle, there are often options that are an improvement on what you might currently have. You could share lifts with people. So if there's a few of you who live on the same road and you normally all individually drive to school, for example, you could go in one car and then you're only having one car trip instead of, say, 3. You can turn your engine off. So don't sit in a car park or at traffic lights with your engine on. That's producing emissions that are completely unnecessary because you're not going anywhere. So often parents are very guilty of this. So next time you're in a car and your parent has their engine on and you're not going anywhere, ask them if they really need that. Then at the bottom, we've got things like you could take public transport, go on a bus or a train. You could cycle or walk. And this picture here of someone with 2 children behind them, that's to indicate a walking bus. So that's when you would have a group of people walking a route to school and picking up people as they go on their way. So that's just a supervised way of walking to school. So those are just some of the things that we can all do in our lives to both reduce exposure to air pollution and reduce the emissions. So I would like you to all have a think about how you would design a clean air superhero. So this is mine. I've called her Fume Fighter, and her superpower is that she removes pollutants from the air. And what you need to think about is how your hero protects people. So she needs to do some things that will protect people from air pollution or stop the air pollution getting in the air in the first place. So I've talked about a few things that you can do to reduce your exposure and reduce pollutants from entering the air. So have a think about what your clean air superhero would look like. What would they look like? What would you call them? And what kind of things would they do to improve air quality or to protect people from air quality? Finally, we can all do little things that will help when it comes to air quality. So what do you think you can do? What would work for you and your family? What little steps do you think you could do to help? Could you ask your parents if maybe you could walk to school one day a week instead of driving every day, or catch the bus, or maybe share lifts? So have a think about what might work for you and that you can promise to do to improve air quality. So thank you very much. That's the end of the presentation, and hopefully you've enjoyed that. And I know for a lot of you it's your first day back at school. So yeah, if you've got any questions, please put them in the chat, and they will be passed on to me and I can see if I can answer them.
Right, thank you very much, Jess. Yes, we have got some questions coming in, but that was really an interesting, engaging talk, and I must admit I did get some of your questions wrong, so I have learned some things today. So I'm going to hand you over to my colleague James, and he's going to put some questions to you now.
Thank you, Lisa. Hi, Jess. So the first question we've got is, does weather affect air pollution?
Yes, it does. So when I'm doing my dispersion modelling that I briefly mentioned to predict air quality, we do include meteorological data, that's a posh word for weather data, particularly wind direction and wind speed. So in the UK, the wind direction comes predominantly from if I don't get this wrong, comes from the southwest. So you can have situations where you would have higher concentrations on one side of a road than the other because the wind is usually blowing in one direction. It's particularly important for dust. And also you see seasonal variations in concentration. So you get higher concentrations of nitrogen dioxide in the winter compared to in the summer. And that's because of the chemical reactions that go on in the air. There's a reaction between ozone and NOx that can form nitrogen dioxide. So it's not the main thing that we look at. The main thing is the emissions coming out of the back of vehicles or out of the chimneys. But yes, it can definitely influence the concentrations. Good question.
Thank you, Jess. And the next one we got is, how long does it take to undertake an air quality report?
That's a very good question. So it does depend on how complicated the situation is. So sometimes we will be inputting into what we call environmental impact assessments, which is where all sorts of different aspects of the environment are taken into account. And those can take a few months to pull together. So the main thing for air quality is that we need traffic data. And so we have to wait for the transport consultants to work out what impact the development is going to have on the traffic flow around the area, and we can't do very much until they give us that. So it all sort of links to all the different topics linked together and feed into each other. So from start to finish, a full impact assessment can take up to a year for a full environmental impact assessment. On the other hand, if it's just a really small development and we don't need to do any modelling, it's really just making sure that there's no adverse impacts, we can probably do an air quality assessment in 2 to 3 weeks. So yeah, it can vary a lot depending on what needs to be taken account of.
Thank you very much, Jess, for that one answer. Sorry. And the next one we've got is, how often do you monitor air pollution?
So, the local authorities, so your council where you live, they have an obligation to look after the air quality in your area. So most local authorities are doing some amount of air quality monitoring all the time. Often it might just be the diffusion tubes that I talked about, the cheaper, easier way of monitoring nitrogen dioxide. But almost all local authorities across the country have a regular network of diffusion tubes that they maintain. So they would be monitoring all the time. When consultants like me do an air quality assessment, sometimes we will need to go out and do our own monitoring. If it's a complicated development and there isn't any air quality monitoring in the area already, we will go out and do our own diffusion tubes. So we probably do that for, I'd say, about a quarter to a half of the assessments we do. We have to do our own monitoring for. And it also depends on what you're looking at. So we also often monitor construction sites, but that would be for dust, just to make sure that they're not causing annoyance to people that are living around them. So yes, there's a big national network of diffusion tubes and continuous monitoring units that's operated by the local authorities. And then sometimes we do our own on top of that. I hope that answers that one.
Thank you, Jess. And the next question we got is asking, how much does deforestation and cutting down plants affect air pollution?
This one is surprisingly complicated. So obviously cutting down trees is not great for an environmental point of view. I'm sure you all know the links between trees and climate change, because trees take in carbon dioxide and give out oxygen. But when we're talking about local air quality and air pollution, we're not really looking at CO2. That's a global or a regional issue. We'd be looking at, like I say, nitrogen dioxide, particulate matter, and a few other minor ones that crop up in certain situations. Now, trees can have beneficial effects and negative effects on local air quality. So what can happen if you have a lot of trees or all along, alongside either side of the road, is you can cause a canyon effect. So you normally think about this in cities where you might have buildings along both sides of your road, and what happens is the air pollution gets trapped and it sort of goes around in circles and builds up and can't escape out of the top of the canyon. So if you create canyons with trees, then that can lead to higher concentrations than you would like. But equally, if you plant trees in the right way, and they can act as barriers, and sometimes, and also if they're planted correctly, they can increase turbulence in the air, which increases how quickly the pollutants will disperse and get lower in concentration. So that one is a complicated one. It's not straightforward. I would say, though, that usually your default position is don't cut down the trees.
Thank you very much, Jess. Sorry for that very complicated question. The next one we got is from Anonymous, but they've asked, how is dust created?
Dust is created in lots and lots of different ways. So indoors, you might know this already, but it's not a very pleasant thought. Most of the dust that you see is actually dead skin cells, which is a bit horrible. and sometimes a reasonable amount of pollen and things like that. Outside, a lot of the particulate matter, so some of the particulate matter and larger dust is from the burning of the fuel in the car, but a lot of it comes from what we call brake and tyre wear. So every time you brake, you're causing friction because you're putting the brake pad onto the wheel to slow the car down. And what happens is tiny bits of the rubber come away from the tyre. That's why you need to replace the tyres on your car every so often. So the friction of the brake pad against the tyre and the tyre against the road, that can cause quite a lot of dust. The other way that is common in the type of assessments we do is resuspension. So dust and particulates that have settled onto the road get lifted back up into the air by the wheel going round and round. And then if we're talking about construction sites, because they tend to be a big issue for dust, there's all sorts of ways dust can be created. So if the delivery lorries aren't covered with sheeting, the dust, you know, if they're bringing in sand or cement, that can just blow off the top of the vehicles. If you're destroying concrete slabs, you're digging things up, all of those things can cause dust. So it's usually from wear and tear of things that dust is created. I hope that answers. I hope that's what you meant.
Thank you very much. And on that note, they've actually said also, how can you get rid of it? So how can we actually reduce the dust
in particular? So dust, really, you need to stop it happening at the source. So when we do a construction dust assessment, we think about what is creating the dust and all the things that on the construction site that are causing it, and we put in what we call mitigation measures. So mitigation measures are things that we can do to stop the dust occurring in the first place. So for example, if you have a circular saw, you can have like a vacuum, like a hoover attached to it, so it will suck all of the dust straight into a bag rather than letting it fly off into the air. You can do things on the site, like I say, like putting sheeting over stockpiles of things to stop things getting blown off by the wind, that kind of thing. You can also put measures in place to stop the dust from escaping the site. So you can use water sprays to dampen things down, because when things are drier, the dust is more likely to get picked up into the air. So in this country, it's not too bad because it rains on a regular basis, but obviously in some countries where it doesn't rain as much, dust is an even bigger issue. So yeah, it's about putting things into place to try and stop it being created as much as possible in the first place. Does that make sense?
Thank you so much, Jess. Got time for maybe just a couple more questions. The next one we've got is, how much of a difference will electric vehicles make to air pollution?
That's a fantastic question. So in terms of nitrogen dioxide, they make a massive difference because you've got no tailpipe emissions of nitrogen dioxide. However, particulate matter, they aren't such a magic cure. Obviously, you haven't got the engine releasing particulate matter, but you still have the brake and the tyre wear that I talked about earlier. And actually, because electric vehicles are heavier than standard vehicles, there is more brake and tyre wear associated with them than with standard vehicles. So if everybody switched to electric vehicles tomorrow, we would have no more NO2 emissions from road vehicles. And so that would make a huge difference to the nitrogen dioxide concentrations in this country. There are still quite a lot of emission sources, such as gas boilers in your home, for example, but the technology on those is improving all the time, and road pollution is the main source of NO2. So in terms of NO2 on its own, switching to electric vehicles would put me out of a job. But in terms of particulate matter, it's not so straightforward for a couple of reasons. One, as I mentioned, they still have a significant amount of brake and tyre wear. And secondly, because road transport isn't such a dominant source for particulate matter as it is for nitrogen dioxide. For example, when we're looking at PM 2.5, the really tiny particulates, there's quite a lot of quite a reasonable proportion of that is actually comes from outside of the UK. We get a background concentration of pollutants coming from the Sahara Desert, for example, which obviously changing the type of vehicle is not going to fix. So it's a mixed picture. It's definitely beneficial for air quality, but it isn't going to solve everything. Hopefully that answers that one.
No, that's perfect, Jess. And that's time's fast approaching. We want to thank everyone, and I'll just pass you over to Lisa. But thank you so much, Jess, for answering all them questions for us.
Yes, thank you very much, James, and thank you to Jess. That was really interesting. And thank you to everyone for joining us. We hope that you feel inspired to help protect the environment and go and tell mum and dad to go and buy an electric car. No, we don't want to put you out of a job. Honestly, Jess, we don't. We're grateful.
No, please do.
So thank you again, and we are celebrating Green Careers Week this week, and Jess has kindly kicked us off. We have another talk on Thursday at 1:30 featuring Jen, who's a STEM ambassador from the Manta Trust, and you can learn about incredible ocean creatures and some thrilling discoveries from the past decade. So yeah, have a look at our website, which is the STEM Hub. And thanks a lot for joining us, and thanks again to Jess. Goodbye, everyone.